All right, this is going on page 135 when we're done. Okay, so average rate of change. What do the words rate of change algebraically make you think? Slope. Good. So average rate of change. Okay, we talked the other day about constant rate of change, average rate of change, instantaneous rate of change. So the instantaneous rate of change was what we used the difference quotient for, right? Which is what we'll use derivatives for in calculus and so forth. Average rate of change, and for what you've been doing with lines, average rate of change and constant rate of change are kind of the same thing, but when it's not linear, that's not true. So we're going to do a quick slope review. Now slope, I mean, this is seriously like a review because definitely Algebra 1, pretty sure you're introduced to slope before Algebra 1, but I don't know that for sure. But either way, you've been doing slope forever. I only taught Algebra 1 for a very short period of time, many years ago, but I taught pre-AP geometry for years, and I'd have to reteach slope. So when I retaught slope, we do this whole lesson. I'm going to give you the short version because I still think it may help a couple of you. I don't know that y'all really have a big issue with this, but still, I think it's a good little visual to have so you don't think wrong about things. So I want you to kind of just draw this little shape like this. Oops, let me try that again. Do it from straight on. Okay, just something similar to what I have. It doesn't have to be exact, but. Okay, so we would do this activity called skiing the slopes, okay? And so I'd have them draw this, and then we'd talk about snow skiing. Okay, so I would imagine that most of us have probably not been snow skiing just because of where we live, right? Doesn't mean you couldn't go on vacation. But if you have been snow skiing, or if you were going to go snow skiing, let's say you've never been and you're going to go, okay? It's going to cost us a lot more money than people that live up north. Would you agree? Because we have zero clothes that work for snow, like zero. So we have to buy all new outfits, we have to buy ski clothes, we have to rent, or at least rent it. Like it's going to cost a ton of money, right? So we're going to pay all this money, and we're going to go skiing. And so so we would draw little skiers. We're not going to bother drawing skiers, but we would draw a little skier skiing up the slope. Now, if you spend all this money, did you go so that you could ski up slope? No, that's bad, right? That'd be really like you fell, or your friend fell and you had to walk back uphill to kind of get to them. And you're thinking like, poor me. This is not why I came skiing. So poor me, the P for this would be a positive slope. Make sense? Now, when you drew your little skier going downhill, that's why you went skiing, right? So we're like, nice. This one looks a little scary, but it's okay. So nice, that's for negative, right? So that helps you visualize positive and negative slope, which again, I'm hoping none of us really have a big problem with. But if you do, you can picture the skier. Then, so this horizontal line here, that's like when you're walking back to the ski lodge, right? It's not nearly as bad as walking uphill, or skiing uphill, which is really more like walking uphill. Not as fun as skiing downhill. It's just not, I mean, there is cross-country skiing. If you enjoy cross-country running, maybe you enjoy cross-country skiing. But again, I think that's not the majority of us. So this is just not really why we came. So we say this is zero fun. And there is literally zero slope for you to ski on. If you think about skiing, there is no slope. Okay, that is zero slope, which is not the same as no slope. I shouldn't have said those words. Then if you get to the cliff, and there is not a slope at all for you to ski on. So we draw this little skier that fell off the cliff. And I always say, well, there's a lot of things you can say when you fall off the cliff. But we say, oh no, because that's no slope. The slope is literally not there. It is undefined. So if you have an issue keeping up with zero and undefined, think about there is not a slope that you can ski on. It is completely undefined. There's no way you could ski on it. You with me on that? So that's kind of a little visual, do a whole thing about a lot of other stuff, but there's your slope. All right, so then we know that slope is delta y over delta x, change in y over the change in x. Right? And we can find that a few different ways. So if we have a graph, like in number 1, and there's 2 points that are actually identified for me, those are the 2 points I want to use, so I'm not, so I'm not guessing whether or not it's actually there. What are our magic words for slope? What over what? Rise over run. So from this point, I would rise 3, run 4. There's my slope, 3/4, right? We're not going to do every single one of these questions, don't worry. Let's jump to number 3. What's the slope in number 3? 0. There's zero slope. There's nothing to ski on, right? Okay, so let's look then at number 4. So number 4, if I want the slope, that is delta y over delta x. So my change in y, That's negative 7 minus 3 over negative 5 minus a negative 9. Then I have to make sure I don't make a sign error, right? So that's negative 10 over what? 4. So my slope is equal to negative 5 halves. Piece of cake, right? We're not going to make this harder than it is. All right. So there we go. That's your little slope review. Don't ever mess up on slope ever again in your entire lives. All right, so now we're going to talk about average rate of change, okay, which can also be what? Which can also be abbreviated as AROC. Average rate of change is AROC. Instantaneous rate of change is IROC. IROC and AROC. So this little blurb up here, it says for functions, but I left out a word. This should say for linear functions, or linear. For linear functions, the slope is constant, right? That's what makes it a line. It's a constant rate of change. For nonlinear functions, the slope changes. So remember we talked about the rate of change changes. So with that parabola that you have there, the rate of change changes as you go through. And that is, so what we can do, because we're not talking about, we're kind of taking a step back. We're not talking about instantaneous rate of change, but I can find the average rate of change for my function. Okay? And if I look at, oops. Oh my goodness gracious. If I look at these 2 points here, there's actually a theorem that we'll get to in calculus that talks about the fact that the average rate of change is going to be the same as the instantaneous rate of change somewhere along the way. So somewhere maybe right about there, my tangent line would have the same slope as the secant line, right? And then, you know, but that we can kind of estimate it with 2 if we're not sure how to find it with just 1 point. So the average rate of change for a function between 2 points is the slope of the line that passes through these points. That should make sense, right? And I just said it when I didn't mean to, so you should be able to tell me what is that line called when it intersects at 2 points? Secant line. This is a secant line. That's what that is right there. Okay, so the formula for the average rate of change. Remember, this is just slope, and the interval goes from A to B. So that's an interval of the domain, closed interval, or going from A to B. The average rate of change going from here to here would be the slope of this line. That's how we find it, right? And remember, if I moved B closer to A, then the slope of this line would get closer to whatever the tangent line is there. Or we can move them both together and get it somewhere around here. But we're looking for the average rate of change. That is the slope of the secant line. So slope, M, little subscript of secant. Okay? And then remember, it's y2 minus y1. Well, if this is A, then the y value here is f of A. If this is B, then this y value is f of B. Would you agree with that? So this is really equal to f of B minus f of A over B minus A. Everybody good with that? Okay, so let's look at number 7. I've got this interval from -2 to 1. All right, so when x is -2, y is what? 1. When x is 1, y is down here, right? So my interval goes from, this is A, this is A right here, this is B. So I'm going from the average rate of change going from -2 to 1. I'm going to find the slope of this secant line. That's equal to f of 1 minus f of -2 over 1 minus a -2. So what is f of 1? negative 8, and f of negative 2 is 1. This is, if I can draw it well, which is probably not, here's my secant line, right? So the slope of that line, so something I know for sure about the slope of the line since I have a picture, is the slope positive or negative? Negative, so that's something that I want to make sure I pay attention to. And so then f of 1 is negative 8 minus 1 over 3. So that's negative 9 over 3. Slope of the secant line is equal to negative 3. What questions do you have? We good? Okay, so I know that we can find slope. I know that we understand slope. At least I hope we do. We should. So what I really want you to focus on here is notation, what you have to write down to show your process, which the great majority of you really listened when I talked about that with limits, did a great job on the test doing that, leaving the limits notation when it needed to be there, taking it off when it didn't. Some of us still don't understand that, but overall you did. So that's kind of something I want you to focus on here too, because yes, is this easy? This should be easy, but we got to make sure that we're writing what we need to write. Okay, so let's look at number 9, okay? Average rate of change. Anytime you see rate of change, it should make you think slope, and then you got to figure out which one. Well, this is the average rate of change. It is the slope of the secant line. So I want the slope of the secant line. That's going to be equal to. Now, they have to give me an interval for that. They gave me the interval. This is my A, this is my B, right? So this is going to be f of negative 7 minus f of negative 9 over negative 7 minus a negative 9, okay? And you may think it's stupid to have to write that out, but I'm telling you, you're going to have to do this kind of thing in questions that seem really complicated and they're not, and you need to write that so that you can then think about what you need to go find when you have to go find it differently than just looking at a question like this, okay? So then, things we need f of negative 7, right? And we need f of negative 9. So f of negative 7 is going to be 2 times negative 7 squared plus 28 times negative 7 plus 93. F of negative 9 is going to be 2 times negative 9 squared plus 28 times negative 9 plus 93. You substitute it in, okay? And yes, you have to write that down, okay? And then now you can let the calculator do that for you. Find those two values. What did we get for f of negative 7? Negative 5. Did I give you enough time for the other one too? Maybe, maybe not. You're still typing. 3? Okay. All right, so now I can come back over here. F of negative 7 is negative 5 minus 3. Negative 7 minus a negative 9 is a positive 2. So the slope of the secant line is, let's read negative 8 over 2, which is negative 4. Okay, so I'm going to let you in on a little secret, okay? When you are taking the AP Calculus exam, right? So again, I know not all of you are, but this is a pre-calculus class. That's why we talk about calculus so much. Then there's such thing as that's called a safe stop, right? That means that, let's say all I needed to do to finish the question, whatever it may be, is evaluate f of negative 7. I could stop here. That is f of negative 7. That is a safe stop. Now, in this particular question, it doesn't really make sense to stop there because I would have to rewrite a lot and it would just be nonsense, right? But that would be a safe stop. If what I actually wanted was the slope of the secant line, then I actually could stop here. Actually, I could stop at negative 5 minus 3 over negative 7 minus a negative 9. Because nobody's testing your ability to add and subtract numbers. It's, do you understand that you're supposed to find the average rate of change? Do you know what values to use to find that, and so forth, okay? So that's why learning to actually substitute stuff in without calculating anything along the way. Do you know what negative 7 squared is? I think so. But I'm not writing down 2 times 49 there. You literally just substitute it in and stop, because sometimes you get to completely stop right there. I'm not talking. Oh, he told me 49. Thank you very much. You're right. So that's one thing you want to start practicing a little bit more. You can do it in your head. Great. Nobody cares. Because first of all, you have to show process. Second of all, have you ever messed up when you've done stuff in your head? Yes. So don't do it. Like, don't do it. And that's a hard thing to kind of switch sometimes, because you're so used to having to work everything out. And again, still here, you would want to get it to these numbers, because leaving it like that to finish the question over here is kind of nonsense to leave it like that. But it is a possibility depending on the situation. Okay, you good with me? That's why I want you to practice on actually substituting this stuff in, writing specific things down, and whatnot. Okay, let's jump to number 12. So again, I want the slope of the secant line. And so I write down that this is my interval from A to B, so that is f of 7 minus f of negative 1 over 7 minus a negative 1. So then I'm going to go off over here, and I'm going to find f of 7. That's going to be the square root of 7 plus 5. And then I want f of negative 1, and that is the square root of negative 1 plus 5. Then you go ahead and finish this question up. And by the way, I'm letting you use calculators just because it's fine. But these types of questions with these types of numbers, these would be non-calculator questions for sure. Okay, because this would technically be a non-calculator, it's okay that you finished it off on a calculator, but I want to think through this as if I didn't have a calculator, right? So the square root of 12 is 2 square roots of 3. If I substitute it in and I get this, can I just reduce this 2 and this 8? No, 100% no. And even though there are safe stops, like I could stop there if this was on the AP Calculus exam, which it's not, so I do want you simplifying this stuff. But on the multiple choice questions, they may be simplified. That's why you still have to know how to simplify it, because if your answer doesn't match theirs, you have to simplify it so it matches. Does that make sense? That's why it's still important to do both. So I would need to factor out that 2. That would give me the square root of 3 minus 1 over 8. And then that reduces, and that's why the slope of the secant line is equal to the square root of 3 minus 1 over 4 when it's completely simplified. So it still is important that you can calculate everything out. It just depends on what kind of question it is, whether you'd be able to stop or not. Okay. What questions do you have? Okay. So let's look at 13. A company's total cost, C of X in dollars, to manufacture X units is given by this function. Find the average rate of change of the total cost for the first 200 units manufactured. Okay, so in order for me to find the average rate of change, I have to have an interval for the domain, right? I know that my Y is C of X, right? What is X? What is X in this question? The what? X units. Right there. X is the number of units, okay? So what would my interval be if I want the cost for the first 200 units? It would actually be 0 to 200, right? Because there's a cost before you actually, there's a cost to run stuff even if you don't actually manufacture any. So for the first 200 units, I'm going from 0 to 200. That make sense? So I have my interval, I have my function. Now I can find, now, average rate of change and the slope of the secant line are the same thing. It literally says average rate of change right here, so we're going to call this AROC instead of the slope of the secant line, but again, they're the same thing. And this is C instead of F, so that means I want C of 200 minus C of 0 over 200 minus 0. So then I'm going to go off to the side over here. I'm going to find C of 200. So that's going to be equal to 0.05 times 200 squared plus 40 times 200 plus 1200. We'll type that in a second. Let's go ahead and write. We also want C of 0. What is C of 0? 1200. All right, so go ahead and find that. Find C of 200. And you get 11,200. Is that correct? That's what I got, yeah. And that means I have 11,200 minus 1,200 over 200. And when you calculate all that out, what do you get? $50. Okay, good. All right, so I'm not going to make you write a sentence, but we do have to state what our answer is and use the correct units. So our average rate of change, our AROC, is equal to 50. And then the way you come up with your units is, what do we put in the numerator? What's represented in the numerator? That's your C of X. What are the units on that? Dollars. So that's 50, and then that's dollars. And the denominator is what? Units. Okay, so this is dollars per unit. That's your average rate of change, $50 per unit. Okay, any questions about that? We good? All right. So now let's look at 14. We're not going to do the whole thing. We're just going to talk about the units. So it says a ball is thrown straight upwards so that its height, h of t in feet, is given by the equation, blah, 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 where t is the time in seconds. Find the average rate of change in the height of the ball from when it reaches its maximum height until it reaches the ground. So we're looking for AROC, right? And so it'll be some number, but then units. This is a rate, so it's something over something, right? What goes in the numerator? It's whatever the h of t is. What are the units on h of t? Feet. H of t in feet. I mean, usually it's told to you. You just got to make sure you're finding the right thing. And it's feet per what? Seconds, because then it would be t, which is time in seconds plus feet per second. What questions you got? Anything? We good? All right.